Hi everyone! Welcome to another edition of Take Charge Math. Be sure to check the reminders on the right for you to be guided accordingly. Our instructional video is divided into three parts: a quick review, an in-depth discussion, and a short quiz. So I hope you're ready. I'm excited. Let's get started. For our quick review, let us apply the different factoring techniques on this exercise. You may pause the video while you work on it. Good luck! Now, let's check your answers. Did you get the same results? For our today's topic, we will discuss the general strategy in factoring complex binomials or trinomials. But don't you worry, I will be here assisting you. Alright, let's start. The general strategy in factoring completely binomials or trinomials are the following. Number 1. Factor using common monomial whenever possible. Number 2. If the polynomial has two terms, check if it is a difference of two squares or sum or difference of two cubes. Number 3. If the polynomial has three terms, check if it is a perfect square trinomial, or if the trinomial is not a perfect square, factor the trinomial as general trinomial. Lastly, continue factoring until each factor is prime. For our first example, let's try 64x to the fourth minus x. We first check if they have a common factor. In this case, the common factor of the two terms is x. We apply the rules in factoring common monomial factor, and that is to divide the common terms with the given. Doing so, our answer is x times 64x cubed minus 1. The next step is to check the number of terms. Here we have two terms. Then we identify whether they belong to the difference of two squares or to the sum and difference of two cubes by checking on its exponents. Based on the given, we will apply the difference of two cubes. We solve for the cube roots of the two terms. For 64x cubed, that is equal to 4x. Then for 1, it's still equal to 1. We follow the pattern in factoring difference of two cubes. Our answer is 4x minus 1 multiplied by 16x squared plus 4x plus 1. For the last step, we include the common monomial factor x on our answer. The final answer is x times 4x minus 1 times 16x squared plus 4x plus 1. Alright, let's try another one. For our second example, we have 180 a squared minus 5. We first check if they have a common factor. The common factor of the two terms is 5. We apply the rules in factoring common monomial factor, and that is to divide the common terms with the given. Doing so, our answer is 5 times 36a squared minus 1. The next step is to check the number of terms. Here we have two terms. Then we identify whether they belong to the difference of two squares or to the sum and difference of two cubes by checking on its exponents. Based on the given, we will apply the difference of two squares. Since the exponent is 2, we solve for the square roots of the two terms. For 36a squared, that is equal to 6a. Then for 1, it's still equal to 1. We follow the pattern in factoring difference of two squares, which is a minus b times a plus b. Our final answer is 6a minus 1 times 6a plus 1. For the last step, we include the common monomial factor 5 on our answer. So we will have 5 times 6a minus 1 times 6a plus 1. Got it? It's quite tedious, but by following the procedures accordingly, we will be able to familiarize ourselves with the pattern that is part of it. Let's try another one. Our next example is 27x squared plus 18x plus 3. We check if they have a common factor. In this case, the common factor of the three terms is 3. We apply the rules in factoring common monomial factor. Doing so, our answer is 3 times 9x squared plus 6x plus 1. The next step is to check the number of terms. Here we have 3 terms. Then we identify if it is a perfect square. By checking on the rule, which is the first and last term must be a perfect square, and the middle is equal to twice the square root of the first and last term, we can conclude that it is a perfect square trinomial. We solve for the square roots of the first and last terms. For 9x squared, that is equal to 3x. Then for 1, it's still equal to 1. We follow the pattern in perfect square trinomials, that is the square of a plus b. Our answer is the square of 3x plus 1. For the last step, we include the common monomial factor 3. Our final answer is 3 times the square of 3x plus 1. Got it? Practice makes perfect, and by doing varied exercises in factoring, we will be able to master it in soonest time. And I know that you can do it. Now, let's move forward to our last example. The given is 15y squared minus 18y minus 24. We follow the steps we discussed a while ago. We first check if they have a common factor. In this case, the common factor of the three terms is 3. We apply the rules in factoring common monomial factor, and that is to divide the common terms with the given. Our answer is 3 times 5y squared minus 6y minus 8. The next step is to check the number of terms. Here we have 3. Then we identify if it's a perfect square trinomial. By checking on the rule, we can conclude that it is not a perfect square trinomial, since the first and last terms are not perfect squares. Then we follow the procedures in factoring general trinomials. For step 1, multiply the coefficient of the first to the constant. Then list all factors of the product. We have 5 times negative 8, which is equal to negative 40. I want you to list all factors of negative 40 in a piece of paper. Step 2. Choose the pair that adds up to the middle coefficient. The middle coefficient is negative 6. What do you think would be the factors? Alright, that's correct. That would be negative 10 and positive 4, since their sum is equal to negative 6. For step 3, write the temporary factors, and that would be y minus 10 times y plus 4. For our step 4, divide the factors with the coefficient of the first term. We divide negative 10 and positive 4 with 5. Negative 10 becomes 2, and positive 4 becomes 4 over 5. For our step 5, move the denominator, whose quotient is a fraction, in front of y. So the denominator 5 will become the coefficient of y in the second term. Our answer is y minus 2 times 5y plus 4. For the last step, we include the common monomial factor 3 on our answer. The final answer is 3 times y minus 2 times 5y plus 4. And we're done. Remember that you may play this video over and over so that you'll have a better mastery of the topic. Now, let's proceed with our practice problems. For our short quiz, I want you to try to answer these problems. You may pause the video for a while to give you ample time. Alright, good luck! Now let's check your answers. Did you get the same results? Congratulations! Thank you for your active participation. I hope you learned a new skill again on this video. You may watch it over and over again to give you a good grasp of the competency. Also, for additional mathematics resources, you may subscribe on my channel so that I can better assist you in your journey. Again, thank you very much and see you soon.